Well, yeah, that's a good question, because when I have the mic on, sometimes people are like, oh, does it pick up what students say, right? Not really. I know. Sometimes if someone's really excited or loud in the background, it comes up, but it's mainly proximity, so it picks up my voice. Maybe you'll have to listen to this one, so you can check that afterwards to see. Yeah, dividing monomials video. Okay. Here we go. We'll add. It's a good idea. I don't know if you have ever watched something called a sitcom on TV. That's when you're watching the show, and at certain times people will laugh. At certain times they'll cheer, and they actually have people watching it in the crowd, but they hire people to give cues, right? So that would be a cue. So we're going to try this during this video, okay? So sometimes I'm going to put this up, and we need a concerted effort. You guys are terrible. You would not be allowed to come watch shows anymore if you were at a sitcom. So if this goes up, you cheer loudly and even maybe break your cast or wrist guard or whatever. Okay, and if this comes up, okay? So we'll try to do this correctly with our dividing monomials video here. Here we go. So dividing monomials is like, and we can put this with algetiles. We're not going to use algetiles a lot. Dividing is the opposite of multiplying. So in algetiles, if I had 3x times 2x, I could draw that, and some of your homework will have this. You'd put 3x along one side, they'd be shaded in, and 2x along the other side flat, and they would be shaded in. And the area that this shape makes is the answer when you multiply. Well, what would you fill this up with? This part from here to here would get filled up with an x squared. You would have another x squared here, shaded in, shaded in. If we had our algetiles out, we could make a rectangle if one side was 3x and the other side was 2x, and it would equal to 6x squared, which is our multiplying already. When we get to dividing, we have to think opposite of multiplying. We know the area, and we know one side. What would the other side be? And so 6x squared divided by 3x, according to the algetile model, you would not know this side. You'd put your 6x squareds in there so that they fit with 3x on one side, and you'd be trying to find the other side. And the answer is 2x, because that's in that red circle what was missing. What are we going to do that makes this easier algebraically? How do you think I'm going to get the 2 if I have 6x squared divided by 3x? Where does that 2 come from? Well, if we multiply the coefficients when we're multiplying, does it make sense that we'll divide the coefficients when we're dividing? And 6 divided by 3 is 2. And if when you multiply, you add the exponents, what do you think you do when you divide? You subtract the exponents. Because technically, this means you had 2 x's on the top and 1 x on the bottom. And we learned from multiplying, dividing fractions, if things are the same, you can simplify them. So those x's would cancel each other out and simplify to 1 over 1, and you would be left with just one x. But it's the same idea as, because when they simplify away, it's like subtracting them. All right. Okay. Well, now let's see if I can get one right and see if, okay? So, are you ready? Okay, okay. All right, here we go. 8 divided by 4, I got 2. Okay? And then I have an x on the top, but my y's would cancel out. So the answer to this one is just 2x. Right. Okay. Good stuff. Okay. Try this one on your own. Did you get 27 divided by 9 is 3. And x squared divided by x would just be an x. Sometimes the dividing is just written this way with the dividing sign. You could rewrite this as a fraction if you'd like. And you'll find that as you get into higher mathematics, you use this fraction more and more. And the division sign sort of goes away. It gets forgotten. It goes and hangs out with the number 13. Ooh, negative divided by positive. Negative. And these m's are identical, and you're dividing, they'll simplify away to be 1 over 1, and we're just left with negative 5n. How did we do? All right. Okay, that last cheer, I don't know if it'll be on the video. So you have to check. Here we go. We'll pause it.